Okay, so here we are. We have placed the parts for our assembly into one file, and we've oriented things such that they're kind of laid out the way it's shown in our exploded view drawing. Now we need to kind of assemble everything. And when you're assembling, it's a good way to think about how the parts, if they were real parts, would actually be put together in real life. So if you recall the video of the caster wheel assembly, you can try to follow the process of how that was put together. I know it was a little different in construction, but it did have essentially the same um, relationship of components to make that assembly. So when I look at this, I see that this post goes into this bracket. And then if I look at my exploded view drawing, it says that it gets peened at assembly. So basically they would put it into one of those presses and they would smash the bottom face of this post to expand it so it would stay inside this hole. So if you picked up the post, the bracket would come with it. So we'll start with that, um, assembling those two items, and then we'll put this bushing into the wheel. So that would get pressed into the wheel in real life. And once that was done, the wheel plus bushing would go into the bracket, and this shaft or pin would be inserted through everything. And this retaining ring would seat itself in this groove in the end of our pin and hold it all together. So the first step to beginning the process is we're going to constrain everything together. Remember I said how everything can basically move freely? Once we're done constraining everything, it should all be attached. So if you grabbed one item and tried to move it, the whole assembly would basically move. So we use this command, it's called constrain. And when we use constrain, like most of the other commands we use, we get a pop-up box. And there's different types of constraints. You can see we've got a mate constraint, a angle constraint, a tangent constraint, insert constraint, and symmetry constraint. We're only going to use two of them for this assembly. We'll use the mate and we will use the insert, and primarily we're going to use the insert. So for this first attachment, we'll select insert and we will select our two selections that will be inserted. So number one, you can see we're selecting, we'll grab the post, and number two will be the shaft, the hole in the bracket. So you can see it's placed those two items together. Here you have two different solutions. So if you toggle between them, you can see it's flipped the post down and now it's sitting inside the bracket. This is the orientation we want, but what we don't have is this bottom of this flange. If I zoom in, the bottom of this flange should be sitting on the top of this bracket, but we can fix that. There is an offset here that will change the relationship between this post and the bracket. So basically I want to change this offset. So I bring this post down to fully seat inside this bracket. For now, I'm going to click OK to keep what we have. And now I'm going to just take a look at this. In my main toolbar, I can go to the inspect. I want to measure it. I want to see what that offset needs to be. So I measure from the bottom of my flange to the top of my bracket. Inventor is telling me that that offset is 6 millimeters, which is information I need. Now, if I go to the browser and I expand the bracket, I can see that insert constraint that I've added. And what's really handy is if I click on that, I get this little pop-up and there is our offset. So now we could put in 6 millimeters, we could hit enter, And we can see that rather than seating the two items together, we kind of went to the opposite of what we wanted. But it's not an issue because if you use a negative value, so negative 6 millimeters, it'll go in the opposite direction. It'll give us the constraint that we want. So I can click anywhere away from that pop-up offset value just to get out of it. So I'm going to go back to the Assemble menu. And next we said we were going to assemble the bushing with the wheel. So again, we'll use the constraint, and again, we will use insert, and we will grab our bushing, and I'm going to zoom in and orbit, and then we will grab the hole through the wheel, and you can see how that axis arrow comes up, showing how those can be attached. Now in this case, it's aligned them. I mean, they're concentric, which is what we want, but it's aligned the end of the bushing with the side of the wheel. We kind of want the opposite of that. So we can come up here, click the other solution, so you can toggle between solutions and find the one you want and apply it. Now, one other thing I would like to do with this constraint before I leave is I want to fix this bushing inside this wheel, and you'll see why later. So I want these two things, if I move them along the axis arrow that you see, I want them to slide together. So to do that, I can add a constraint that makes this surface of my wheel flush with this surface or end of the bushing. So we use the mate, and we will grab that surface and this surface. So they're both selected. Now I can see by the solution, I definitely want them flush together. I do not want them opposed. So make sure you use the solution where they are both flush, and you can apply that. Now if we grab the wheel, you can see those two parts are together. Same with the bracket. And next we can put the wheel into the bracket. And we'll start by going to our constraint box here, using the insert type of constraint. And I'm going to use my bushing. And where I grabbed on the bushing, I want to align with the bracket. So if we look at the side of this, we can see those two things are concentric. So the wheel is where it should be in relation to this hole in the bracket. But I want to show you something. You can see that it's not symmetric. So I would like, instead of having one big gap on the left of the wheel, I want two even gaps, one on the left and one on the right. For now, and we're just going to click OK. And we're going to use the similar type of measurement and changing the offset value to get the even gaps, okay? So I'll go back to inspect. I'll use the measuring tool. And I'll select this face and this edge. And it tells me that that's a 2 millimeter gap. So I would like to offset that by half of 2 millimeters, which would be 1 millimeter. So I can go to my bracket and I can find the right constraint. So that was the most recent one we added, which would be this insert 3. And I can enter in a value of 1 and click enter. And let's see what happened. So now when I'm looking at that straight on, I can see I have a 1 millimeter gap on the right, as well as a 1 millimeter gap on the left, which is what I want. So next we can attach the shaft through the wheel and the bracket assembly. So we'll go back to assemble. We'll use the constraint tool, and we want an insert type of constraint. I've got the shaft, and now I need to select the wheel, and I click. It makes that funny noise to indicate that it has constrained those two items. And I can zoom in. I can see that I've got the groove of my pin or shaft is ready to accept the retaining ring. So I'm happy with that. I'll click OK. Now we're down to the end of it. What we're going to do is we're going to constrain the retaining ring into that shaft. So we'll use actually the mate constraint. And the best way to do this that I found is to click on this line of the retaining ring. And you'll see that the center point, that green circle that pops up, that's important. That tells you that with this edge, I'm basically going to mate this point, the green circle, with its counterpart over here on the shaft. So select there, and the two items constrain exactly how I want them to. Click OK, and we'll go to our home view. Now we can see we've got the caster wheel fully assembled. And if you grabbed anywhere on the part and just try to move it, you can see that everything's attached just the way you want it. So now you could save the file and you would be done the activity. Thanks for watching.